Good afternoon. Welcome to Fantastic Red Team Attacks and How to Find Them in South Seas ABE with Casey Smith and Ross Wolf. Before we begin, and as people are sitting down, I'll give you a few brief announcements. Make sure you stop by the Business Hall in Mandalay Bay, Oceanside, and Shoreline Ballrooms on level 2. The Black Hat Arsenal is also in the Business Hall on level 2. Don't forget the merchandise store on level 2 and the session recordings from Source of Knowledge. They have a desk on every level. Please and thank you for putting your phone on vibrate. It makes us easier for the rest of us to ignore the ringing while we wait for your voicemail to pick it up. Let's give it up for Ross and Casey.
Good afternoon. Thanks for coming out to our talk. A couple of things that we want to talk about here is take a question-based approach. So some of the questions we want to address today are the tools and methodology that you use today working? How would you know? And can you detect attacks that are known? And also, can you detect attacks that are unknown? And so we're going to be sharing some free and open source tools that you can use to help answer the questions that you're interested in your environments. So my name is Casey Smith. I'm the Director of Applied Research at Canary. You can connect with me on Twitter @subt. I also worked on the Atomic Red Team project we'll be talking about today.
And I'm Ross Wolf. I'm a researcher at Endgame. I created our event query language we're going to talk about today, as well as a lot of our detections and our detection system. I'm on Twitter as well at RW_access.
So real quick, so you have an agenda, we're going to be talking about really 4 major themes during this talk. We're going to share a little bit about Atomic Red Team, what it is, how we see defenders using Atomic Red Team. Then we're going to take a deep dive into the event query language, or equal, and we're going to look at the syntax, structure, and how to build queries to search through endpoint data. And then we're going to go through an exercise, which is red versus blue, that Ross and I created in order to test some of the theories we had. And we're showcasing an attack that, based on our research, hasn't been seen before, but we were able to work through that data set and locate it. And then we'll come to some conclusions about what we learned along the way. So we've put a couple of links for follow-up after the talk. So one of the reasons we're here is defenders want to know that their tools and their methodology is working. And the question we have is, well, how do you know unless you actually test and observe outcomes? So how are you actually testing your defenses? And a lot of defenders don't know necessarily how to start testing, or they may not be testing well. So one of the things we're going to dive in today is when we start looking at behavior-based detections, that takes a different way to exercise or create telemetry to make sure your detections are working. And so one of the reasons that we created Atomic Red Team was to help teams have at least a tool that they could use to begin understanding or test some of their detections. Some of you may have heard of Atomic Red Team. For those of you who haven't, it's a free open source project for testing security controls. It's really primarily focused on the endpoint, so we're able to exercise various tests. All of the tests that we've written are based in YAML. We have source code and binaries that back that up. All of it's mapped to MITRE ATT&CK, so that if you want to look at a particular MITRE ATT&CK ID, you could go find the source code that backs up that particular test. And a shout out to Chris Gates. He helped us as teams started using Atomic in an automated way. YAML is a good way to describe tests. Many of the tests in Atomic Red Team are single command line or minimal dependencies to set up a binary, a command line, a local or remote script. And so that's very helpful for small security teams up to larger teams that may be consuming or taking a dependency on using Atomic Red Team. One of the reasons we created it was to demystify attacks. So by providing code and examples. So if you read about a particular attack on MITRE, MITRE's taxonomy, which is a really great repository, but you want to know the details, like what API calls are made, or what files are written to disk, or what file structure is referenced. This helps you as a defender draw your own conclusions about observation and detection. And of course, I just wanted to mention this. When we use the term atomic, we're thinking in terms of discrete or small components. We're not replacing a human red team that can do adversary emulation and adaptation. And so we still see tremendous value that'll come out in this talk today. We use that particular term just to say this is one way you can begin exercising some tests and generating telemetry. What does an atomic test look like? Well, This is an example of the YAML structure, and we can see here we're referencing MITRE ATT&CK technique T1118, which is a whitelisting bypass called InstallUtil. And we can see we have some data that surrounds that particular test that can describe descriptions or references. Ultimately, though, we have what command do you need to execute to exercise this test. So in this test, InstallUtil will load a .NET assembly. It will find the help text method and execute that. So a number of adversaries have used this. We'll talk about it in a moment. And you can change some of the file name properties. So here you see we have a file name and it is replaced in the command line. So you can customize these as you need to. Those are arbitrary. It's up to you to use. One of the benefits of actually describing tests in YAML for automation is it actually helps you chain tests together or put sequences of tests together. We like to call them chain reactions. But essentially we can take a sequence of tests and we can then put them in an array and then call, this is an example of our PowerShell function, and we can call get the technique and then invoke the technique. And so a majority of our tests are benign in terms of they may just pop calc or write a file to disk, but you can customize those to be as aggressive as you may need for your testing. What are some of the observations that we've learned from teams that may be using Atomic Red Team? So one of the use cases for Atomic is teams want to validate collection of their telemetry and detection logic. So we've seen, for example, teams identify misconfiguration because they run a test and they were expecting their analysis engine to analyze the command line, and it never got there. There was a misconfiguration on the network or on the endpoint, so it can help drive or identify gaps in that respect. It can also help you understand what data sources you have. So if you're expecting to understand process relationships, go ahead and let's test that. And if you're expecting an adversary to break process relationships, so parent-child, you can also exercise that as well. Helps you understand your environment. A lot of the tools that we'll talk about in a moment are built-in tools to the operating system, and so helping you understand how are normal tools used and how could they be abused by an adversary. And then lastly, some people just want to know, do I have coverage for this particular technique that I saw or read about? So some of the frequently missed MITRE ATT&CK techniques that we've observed are things that are related to native OS tools. And so you have a few of them here. I'm going to call out, we're going to really focus in this talk on two of them, but just to go through a few that we've seen teams that miss these. So masquerading is a common one. So you may not be familiar with that particular ID, but a masquerading attack would be like just renaming a binary or copying it to a location that's writable by the attacker. So that's a commonly missed test. The Windows management instrumentation is another area that has some gaps in visibility. Process injection. And these are really just things that we've observed talking to teams that are using the tool and providing us feedback. One that we'll talk about today in depth a little bit more is InstallUtil. And we'll also take a deep dive into some trusted developer tools because these are often signed by legitimate companies, but they have really powerful capabilities built into them. MSHDA script hosts, and ready to run arbitrary VB script, JScript, still being missed by a lot of teams. And then of course XSL Script processing. So if you haven't heard of this, would be using sort of non-standard things that can run style sheet scripting, so things like WMIC and format tables and things like that. Okay, so why do we do these tests? Well, primarily because these tests are then seen in actual incidents. So I put two references here for you to look at. And the first one is a reference of an adversary using InstallUtil. And the second one is a reference to attackers using MS-build. So both of those, for example, in the Windows space, will ship by default with the operating system. Adversaries can use those if you're operating in a constrained whitelisting environment because they're already there. They may already be trusted. So that's why we like to run these tests, so you can be prepared for the actual incidents. So ultimately, Atomic Red Teams may help organizations prepare by running small, benign examples and letting teams test, practice, iterate their response, their coverage, and hunting. But the reality is, all of these things that we've talked about so far, they're really known. So an attacker may decide to do something that is not in the MITRE ATT&CK matrix and not something that has been seen before. So we wanted to explore the question of how would you hunt to see if you could find something unknown? So I'll hand it to Ross.
Looking for those known threats, if you will, like the atomic tests that we have, aren't as bad once you understand them, once you can detonate and look at the data they generate. But like if you want to find those known unknowns, like if you know there's going to be an adversary, how can you still find it? What do we still know in general? And there's still like that MO, right? There's going to be privilege escalation and lateral movement, and we can focus on those higher level behaviors. So like behaviors, I mean like the things that they're doing to accomplish their goal, they being like adversary, and the focus we can take instead of on tools is we can focus on events, right? So events logging like state changes and things happening. So if those behaviors are more complex and span multiple events, what if we could chain them together and see, oh, there's a state change, something happened here that was new. That might tip our hand to finding an adversary. And I'm going to go through some EQL to ask and answer some of those behavioral questions. So EQL is a language we released. It's free. It's open source. It's supposed to be really easy and intuitive and simple to use. At least I'd like to think. But also complete enough to answer those complex questions, looking for things happening in a certain sequence or even tracking like process ancestry. And it natively supports like process lineage. Like I could ask like, oh, is this a descendant of that? And that's supported like right out of the box. You don't have to do multiple queries a row. And also looking for sequences of events happening. But we often need to sort through a tremendous amount of data. When you're talking millions of billions of events and you're trying to get to like a couple hundred, you need some way of looking for the outliers. And so we have pipes for that. And it's more than just like this language and spec. If you want to start using it, we'll get into later like how you can use it yourself, but there is this dynamic shell. You can load up your own data and play around with it. So it's also a tool, not just a language. So what's it look like at the most basic level? You can look for a single event, and that's some event type where some condition is true. That's simple. It looks kind of like Python as far as its operators go, like the and or not, lowercase, equal signs, and you can compare strings. You can use wildcards as well. One query example might look like this. So maybe I'm looking for a weird SVC host. Like I know SVC host normally has a -K, and it comes from services. And so I could express that in EQL this way. Here's a process that looks like this and has these fields matching. So I can take that simple component, that event query, and I can actually stack them together into a sequence. So I can look for multiple events in a row that look a certain way. And so that kind of follows this template where we've got a sequence over some time span, if that's relevant, and then between the brackets, you've got that event query again. So you have multiple events that look a certain way, and you can even say they have shared properties in common. So maybe you're looking for like privilege escalation. What about a file that was written by a non-system user that ran a system later? Like that sounds like privest to me. There's potentially, it could be adversarial, it could just be software that's being installed. But this is how you could express that in EQL, and you can note that the file path from the file event is matched against the process path from the process event. So you can do like those kind of SQL like joins in a way. And speaking of, there's also joins. So sometimes you don't always know the order things happen, but you know that they're going to exist. And so you could say, I'm just looking for a pair of things, or maybe 5 events that look a certain way and have things in common. So this is that query. It looks similar to the sequence, but a little simpler. One example is looking for a file event that created like a task, and then a registry event creating a run once key. So this would match only if both of those are met. Another example of a join would be maybe looking for like lateral movement between 2 hosts, right? So the source IP and the dest IP matching, and then seeing those ports for RDP, RPC, and SMB, which are those common Windows built-in protocols for lateral movement. We can also do stateful and really complex questions really easily, and we're using process lineage. So I could say, maybe I want to look for a spear phishing document that came from Office, came from Word, then it was a PowerShell that reached out and made a network connection. I could actually express that just like this. So it's a network event coming from PowerShell, and it's a descendant of Office. And one of the final things we can do is we can actually sort through the data to find outliers. So there's a handful of pipes already there. If you wanted to, you could even like fork the repo and extend them yourself if you want to add new functionality. Here's one example of pipes. One question I thought was, what processes are unique for a specific user? So my thought was, well, there's a lot that are unique to systems, let's just ignore that. But for a particular user, we could remove the duplicates and then count how many are left, and then you've got like a distinct count, and you see how many are matched to exactly one user. So that's like a bit of some of the features. So now I'm gonna like switch over to a demo. So here, yes. Sorry, so let's run equal. So it's got this built-in shell, and so this is gonna run. I can type in help to see what's available. The first thing I wanted to do though was load that data set that Casey gave me. And so he just gave me this fantastic attacks data set. We'll talk about that in just a minute. So right now it's loading that set, looking at all the events in there to figure out what the schema is, right? Like what are the event types, what are the fields, what types are the fields? And so it loaded that up. And now it knows, oh, I've got process events and here are the fields. So as I start typing a query, it's actually auto-completing my queries, and I can even like tab complete and syntax highlighting. So, I mean, I think it's fun. So right now, here's just like the hello world query, right? Look for a who am I. So we've got JSON output. That's not super friendly to read. It's kind of actually hard. So maybe I'd have better luck looking at a table of this. So we could pick the fields, and those are, again, also auto calculated. And so we can see that table. Okay, that's a lot friendlier. So now I can actually imagine how you'd have a workflow where you're going through running multiple queries in a row and seeing those results without needing to have to worry about like a backend maybe. If you just have that JSON file, you can go. I can also just ask high-level questions of the data. How many events are there? And there's 350,000. Maybe I want to see a breakdown by event type, just to see where the high volume is. So right here, there's a lot of image load events and file events. Process events aren't even 2% of this data, and that's actually something that I care about. So we're already going to be focusing on those. So if I go back from this demo quick, I'm going to pass this over to Casey, and he can tell us more about what's in this data set and how I built it.
Yeah, so what you saw, Ross, was profiling a data set called Fantastic Red Teams JSON. And so what we wanted to do was an exercise to test some of our theories, like about give Ross a data set that he had not seen before, and see if he could use equal to uncover a novel threat that I introduced into that endpoint. So what was going on this workstation, we kept it small in terms to really focus on the power of the language. But essentially we have an endpoint with sysmon installed with Windows. We feel like it's a very good way to start learning how to express endpoint telemetry relationships for processes and other data types. We wanted to introduce real background noise. So I let this run for a while and installed several tools on it, and so that Ross would have to decide what was real and what was false positive. So in this data set, there were really 4 things. There's normal user activity. There were some specific atomic tests. I executed a real adversary emulation test, and then I executed a test that, to my understanding, no one has seen before. So the red team objective in this situation, so the endpoint we're targeting was a developer endpoint, because they have a lot of neat tools and a lot of things that may be interesting for us to look at. And so we wanted the mission, so to speak, for this red team exercise was to go find a way to attack that system in a unique and novel way.
And I wanted to figure out, could I actually find Casey? Could I find the red team? So like there's the unknown attack, there's a known attack. Could I also find the false positives and while avoiding all of that normal noise? So going into that, like what was the process that I had in general? And the first thing is I need to get something to look at, right? So I need to gather some initial set of suspicious activity. If you have alerts, you can go off of those, but this was all unknown data. I didn't have anything to go off of, and so I just said, okay, I'm not going to cheat and use any alerts. So I want to figure out how to hunt. How can I use those behavioral questions to look for evidence of a compromise? And while doing that, I need to refine my queries and try to reduce the data set till it's like a reasonable size. Like I need to be looking at this in my eyes to make a decision, so I can't do that for 350,000 events. So I need to get that down to a reasonable size. I also want to triage as I see results, assess are these good or bad. And part of that process also involves scoping, like is this in a process tree that traces back somewhere weird? What happened next? Did I identify what all the adversary or Casey did? And so that first step, like if I'm gathering that suspicious activity, what's my approach? What am I going to do? And so the thought is like I'm thinking first, like what does the adversary do, and what can I do in response? What can I look for? So like the first thing is like an attacker is probably going to need to survive reboots. So they're going to need to make it persistent. So I could look for new persistence locations. But at the same time, if I'm looking, they're hiding, right? So they're going to try to hide from my defenses. So are there potentially like unusual parent-child relationships, like they're using an SVC host to hide, like that example earlier? Or were there other attempts to blend in? Because they want me to think that things are normal and operating, right? But eventually, if there's any hands-on keyboard, there's gonna need to be some callback at some point. either whether that's DNS or network traffic or something else. And so I can ask like what processes started making network connections maybe for the first time? What's new? Or was there like outgoing lateral movement to a host? And so like those are some of the questions that I'm thinking of in my head as to guide my approach for this. So I'm kind of fusing those adversary goals with things that are relevant to my environment. And that's helped me avoid things that are universally evil. We're already contextualized and it saves us a lot of effort. So the first thing I thought was like, okay, knowing Atomic Red Team a good bit, like a lot of that's using built-in Windows tools. Maybe some were renamed. Maybe he thought my command lines weren't that great or I was a little too brittle, too overfitted. So maybe Casey renamed a tool. So I used, I wrote a query looking for the original file name inside that PE header, mismatching what's on disk. Just for a handful of known tools that have been renamed before. And then just removed any duplicates because I don't need to see every single time it runs. So I tried that, I didn't find any results. So I had to like back up again. It's like, okay, well, nothing was renamed, but maybe something was actually used. So maybe those known binaries like that InstallUtil and MSHTA, maybe they made callbacks. So I looked for a sequence in equal to say, give me the process event for any of these known tools, but also it had to make a network event. And by converting this to a sequence, I have the command line and the destination IP at the same time. And that's kind of nice for triaging. So I actually had 8 results, and this is like the first page of results. But before diving into that, I'm going to back up again. So like, what's our process for triaging then? How am I determining what's good and what's bad? Some of those questions there are like, is the path normal? Is this looking like a Windows binary, but maybe like, but not quite, like LSAS with 3 S's, or I guess 4. Or like, was it signed? If something's signed by, not signed by Google, but claiming to be Google Update, you should probably take a look. Or if it was a legitimate product, that's probably gonna tear my hand more towards like, this is a false positive. And if something's been publicly reported, you should always make that like, that's an urgent, it's kind of a no-brainer. So coming back to those results, I actually saw a lot of Atomic Red Team in there. And so I was like, okay, I can assess this. We know that we did an atomic test because in your environment, you're probably knowing when you're doing your own testing. So I can mark that. That's good. That's clean. Then there's the Amazon Sysint thing at the top. And I did some research. And it actually does use MSHTA under the hood and make network connections. So if you try to make a detection like this, you're probably going to run into this FP as well. So there's still one left. But there's still more results to get to as well. So you see more Atomic Red Team at the top. I was like, okay, we can whitelist that. We kind of know we atomic tested it, matched up. And then there's also some Microsoft, some legit Windows reaching out to things that it normally reaches out to. And so I ruled that out. So now I have a few results left. We've already reduced that set down to 4 things. So now let's start pulling some threads. And I'm going to pick that PowerShell up first. So for that PowerShell command, I'm wondering, it made a network connection, but what else did it do? So like, were there any other descendant processes from that PowerShell? And so with equal, I just said, was there any descendant events, any processes from that PowerShell that made the network connection? And I actually had 43 results. I was like, okay, so this is going to be fun, so buckle up. So here's some of the results, but thankfully, their Atomic Red Team, as you can see, I bolded it. And this validates back to like, was this our actual testing? Yes. And we can go through like the full page. All of this was atomic testing. So at this point, you can say like the PowerShell process is atomic. And so we can rule that out. But there's still a next thing left, this invoke Mimikatz. Maybe I probably should have started there. So let's look at that and see what's going on here. And it reads straight out to GitHub, IEX. It's like, this looks totally fine. So where did this come from? What loaded this PowerShell process? Who caused this to execute? So I use the equal sequence to say, give me a process event, take its PID and match that to the PPID of the PowerShell process that ran invoke Mimikatz. So I ran that, I got one result. So that one result's the pair, right? We have the parent plus the child. And this is what it was. The parent was, oh, well, of course, Atomic Red Team. It can be really loud if you have like good detections in place. It's like, okay, so that's good. We can rule that out. There's still one left. This InstallUtil coming from Explorer, which itself is kind of odd, and then making a network connection. Like, how do you get that command line coming from Explorer? Something that I'm also wondering. So what is that? But then Casey said earlier there was like some adversary emulation, and this is a known technique. So this is that adversary emulation. So this is known red team behavior. So moving on, I was like, okay, found a lot of PowerShell. What other PowerShell commands were there? So I was like, what PowerShell commands were run with any arguments, like at least one argument besides that PowerShell. So I just did like star space star, like there's a space somewhere in there. So there's arguments. And just like remove the duplicates and tell me how many you see per command line. So I actually found 3 unique results that way. Once again, we look at see Atomic Red Team all over. So like, okay, cool, this is great. We have visibility into Atomic Red Team, but I didn't find anything. So I'm still trying to figure out what's going on. I was like, okay, maybe I can bring back that question earlier. Maybe Casey's new novel technique is privilege escalation. So maybe he dropped a file, did some crazy, not magic, to get it to run a system. So we can take that example earlier from our sequence and look for a file event created by a non-system user that then ran a system. But that didn't work either. So there could be a priv technique, but this didn't find it. Maybe though, maybe there's still some new type of C2. So maybe some process reached out, made a network connection for the first time. Whether that's a new process or old, I don't know. And so I was like, just for every network connection, tell me the 15 most recent ones to make their first network. And of course that returned 15 results. So there's a lot here, but I'll save you the pain. A lot of these were Microsoft and Visual Studio and all that checked out. So there's still a few left. I looked at another page of results, the remaining 7 or 8. And that's more Visual Studio, and it's Visual Studio reaching out to Microsoft servers that have like Microsoft certs. And it's like, okay, this is Microsoft doing Microsoft things. It's like, we could go down that rabbit hole, but if there's something else here, I'm just wasting my time. So it's like, okay, this is Visual Studio. So we still have a few results left, but that InstallUtil we already saw earlier. We said that was probably that adversary emulation red team. So now I'm wondering, what's this debug serve and, you know, Notepad making a network connection? I don't think that's normal functionality. I think there's something going on here. So I'm trying to figure out, where did this Notepad come from and what the hell is going on? Why is Notepad making network connections? So I wrote an equal query looking for Notepad making a process event and then the network connection. So now I've got the command line, the parent, plus the destination port. This is like everything I think I need. But I actually found 2 results here. So before it was unique, so now we can see all of them. And we see the parent process path is debug serve. I think we saw that a second ago. So what else did this debug serve do? Or DBG SRV? I don't know it's debug serve yet. What else did it do? So I used an equal query. We can actually search multiple event types at once. So if you use like the any event type, it'll search anything. And then there's a field called event type. So I can say anywhere event type is process network file registry. And the process name was debug serve. And then I'll just get the first one for each. And so I uniqued them. So there's 7 results. There's a handful of different PIDs here, so this happened multiple times. As I looked at the first one, I see the command line actually matches with the network connection. So, okay, there's network traffic and it lines up with that, but it came from Explorer. Again, how does Explorer have this full command line? Is it a shortcut? Is it COM? Is something else going on? But then at the bottom, we see this remote debug.msdn.azure.com happened twice with no network, but then eventually it did make a network connection back to the same IP. So at this point, I'm like, what's going on? Why is this reaching out to port 22? Why is Notepad a child process? Why is this making a network connection? Just what's going on? I think I found the new technique, but I don't know what I'm looking at. So Casey, can you tell us?
Yeah. So that was like as we worked through that data set, that was an interesting thing. So I want to talk a little bit about what debug serve is, why it would be interesting, and really the story though is not necessarily about the novelty of a new attack. It's really how we were able to find that with equals. So pretty interesting tool. Some of you may have heard of it before. In my research though, I haven't found anybody using this in a malicious way, but it could certainly be used this way on constrained systems. So functionally, it gives you the capability of a reverse TCP connection, and then you're able to remotely debug a process, and that's functionally equivalent to like whitelist evasion and process hollowing. Did talk with MSRC about this, and again, this is a binary working as designed. It's not an exploit, it's also not default, but it's super interesting for potentially an attacker targeting a developer system because it may already be there. So I was trying to find a debugger tool or some tool that was already installed on a developer system that it would be used in a way that he hadn't seen. So I started looking at tools that were installed when I set up the data set, like Visual Studio, debugger tools, and then I was reading through MSD and really just went through the directory and started asking myself, what is each of these tools that's already on this dev system, and how could I use it to execute code, really was the question. And so you see two commands. You see the server side. In this situation, I just spawned Notepad. I was really just testing the theory here, but you could also spawn, you could attach to another process, or you could attach to a PID. And you can see on the client side, we can see where there's a connection network connection made back using the arbitrary port number. You can use domain names, et cetera. So how would an attacker actually abuse this? So once they get debug serve to execute on a target, now you can use a couple of debugger commands, and this can be automated. I'll take you through it in a manual process, but it's kind of interesting because once I get control for that system from a trusted signed binary, I can simply allocate a region in memory, dvalloc. I can then load my shellcode to the address that I get back from dvalloc, change the instruction pointer, and execute the code. So all within the constraints of a trusted process or a process that I've attached to remotely. So let's take a look at a demo of this. Again, the code here, some of this is going to be manual copy and paste, really just for demonstration so that it's clear what I'm doing. Essentially, we're setting up a server to receive our shellcode callback. So we'll go ahead and set up this box here. There's really three systems in play, the attacker Kali box, and then we'll have two systems, the newts box, or the target, essentially. So here we're going to run debug serve here, and we're going to then catch the callback. You can see debug serve is not running, neither is Notepad currently. And here we are, we're going to receive the connection from newts developer workstation. So got our session running, everything's confirmed. Now we're going to go ahead and launch the attack. So here I was trying to break, I thought Ross might try and hunt for weird process relationships, so I was trying to change that. So I was using COM objects. So I actually ran this with a script host, and then I chained it up to Explorer instead of being chained up to C script or W script. Net effect, he still found it, but essentially we see debug serve is now running, and we see Notepad running in PID 4380. So if you've worked with debuggers before, this is now on my attacker-controlled system, and I'm going to direct commands down into the target. So pretty interesting capability. First, we'll go ahead and breakpoint the process Notepad we're working on, drop in dvalloc. It gives us a read, write, execute region, and then we'll go ahead and take the address we get back. Like I said, all of this can be fully automated. I just wanted to be very clear about what the commands we're doing. So we're going to load our shellcode remotely, change the instruction pointer, just like you would do in various debugging capacities, and then execute our callback. So at this point, now we've piped our shellcode down into Notepad, a trusted process from debug serve, also trusted. There we see PID 4380, just to go back and confirm that our callback came in from that particular host. We'll just go in and look at our sessions and confirm that the PID is where we thought we landed. And from here, you have a lot of options. You could migrate, you could do different things. So that was really the story there was, find something that no one has seen before and see if these detection methodologies and queries still lead you back to the trail. So again, really the story here is not necessarily the power of debug serve being neat and novel. It's how could you find that using these methodologies and query language that Ross just took us through. So if you want a specific detection for debug serve, you can see we've got a sequence here where we're looking for things like any process with a name debug serve or original file name. Attackers might choose to rename it. Outbound network connections and child processes or cross-process communication. But what Ross took us through was pretty manual. So if we're going to do this at scale, how would we actually find some of these things with larger data sets and a larger volume? So I'll let Ross take us through like how you might find these at scale with equal.
Thanks, Casey. So we've got a lot of analytics just like that one that we've compiled together into a library. So we have a library of analytics written in EQL. And like that schema we saw earlier, it wasn't totally anything, it wasn't sysmon. So we've got our own schema there and you can normalize to it. Everything's mapped to attack as well. So the cool thing about that is like if, let's say you're not using sysmon and you're using something else, you just tell it, oh, this field goes to there, and it'll run your query on their data set anyway. And so one example of an analytic in this library, like that debug serve one, this is what that would look like. This is looking for debug serve remote debugger. The technique here that's tagged within MITRE is that trusted developer utilities. And then on the right, we can see there's the sequence. There's that query that we ran. So we've got all the sequence tied to metadata. And the cool thing about that is that we can actually take all of these and just run them at once. Like all those things I asked earlier, it's like, let's just run like those types of queries. And so I just ran a ton of them on a data set, and this is the type of results you'll see. but like earlier, we'll still run into false positives, right? So these aren't always finely tuned, and some of those you have to tailor to your environment. So you have to get a good sense of how do you identify true and false positives. So if you do want to take any of these lessons and turn them into like those highly actionable true positives, you're probably going to want a good baseline of your environment, and you want to update that regularly. Like, what triggered this detection before, and how has that changed since the last time? So you're looking at those deltas and understanding change, and then also paying attention to what shows up multiple times. Like we saw debug serve made a network, but also Notepad. Like neither of them had ever made a network connection before. The debug serve process never ran before. So if we had another one for like first time it was run, or drop, then execute, then network, like there's several things you could do to layer those detections together to get like a more complete story. And by that I mean, like, does this feel like an adversary? Does this look like, oh, it came from Outlook, it's injecting, it's moving, it's okay. At some point you gain confidence, like this looks bad. But there are some things to avoid if you're trying to write your own detections and scale all this up, is that like false positives are everywhere. Like administrators' background software, especially things that are like in your gold image, that's going to be on every machine. So you probably should have a good way to unique them and to keep your ratio of false positives to true positives low. And also, as you're seeing things, like getting that context, like what was the process tree when this happened? What was the user running? Who else was on the box? Like having those questions ready to go when you see anything. But another thing to know is that like we have those atomic tests. We don't have to wait for like a red team to test our posture. There are ways that we can, in several talks as well on like purple teaming. And so we can do that to kind of short circuit a bit of that process. And then the final thing is avoiding like overreactions to trending things. And that can be tricky. It's like, do we detect this? And sometimes that's a thing you have to like have an answer for. But like, so no one's going to be asking you tomorrow, like, do we detect debug serve? I don't know, maybe. But there's still like, do you detect credential jumping from LSASS? Like that is still like a large threat. So like, make sure you have like a good sense to prioritize. So I'm going to pass this back to Casey to wrap us up.
Yeah, so a couple of things there as far as looking at, we talked about how to generate some atomic tests, how do we structure our queries, and then we wanted to leave you with a few things about what you could do to kind of put some of this together to really drive finding gaps or assessing coverage before you're facing an actual test or an adversary. So a couple things that you can do to kind of get started. And again, this is not replacing the full-blown red team scope. We're just saying like these are things that you can do today to start testing, because it's really much better to find a misconfiguration or gap before something actually happens. And so installing, if you're wondering where do I get started with some of these techniques that we showed today in the Windows environment, we've got setting up sysmon. There's various configurations we've referenced here that'll be available after the talk where you can go and configure that. Lots of different event types. Looking at atomic tests, they're not just related to Windows. We do have atomic tests for Mac and Linux, so if you're testing those as well. Then extracting those events, putting them into that JSON format so then you can begin running equal. So installing equal is really just a couple of command lines. Really the dependency there is Python only. And then using the shell, we would love to get feedback, for Ross on like using the shell, getting, ways to improve or how you're actually using it. And then lastly, just start piping the data into equal and begin practicing those queries or building out your detections and testing them against known data sets. So what are some of the things that we can kind of wrap up or conclude as we're thinking about like understanding what data sources you have is very important. And there's a talk yesterday by Katie and Ryan about MITRE ATT&CK and how to use it, how to get started. There's some really good things in there about understanding data sources. So I would definitely check out that talk if you hadn't seen it. Focusing on the commonly seen behaviors, debug serve is new, it's novel. To my understanding, no one's using it or abusing it, but the prevalence of that being very low. Like if you went back today and searched your environment, there's very likely 0 instances of it running, but it's worth going to look and see if anyone has abused it, because sometimes you're not the first one to find a thing. And then practice on those known data sets and then scale up. So really practicing the detection coverage against something that you instrument with test data, like you saw Ross iterating through the queries, and while he was finding the atomic and it was a lot of noise, we were still able to actually validate that yes, this is what I would expect to see parent-child processes. Testing early and often as much as you can, and then again, knowing what resources. Both of these are free resource projects on GitHub, so we would love to get feedback on how you're using it, ways to improve, et cetera. So we put together a few references for you. So if you're curious about some of the things we've talked about in this talk, we talked about MITRE ATT&CK. We've talked about Atomic Red Team, the event query language, and all the references. We also put a lot of this together on the link there you see in the lower left corner. So we do have a little bit of time for some questions, I think, but maybe just one or two questions, and then we'll probably move over to the wrap-up room. But just a couple shout outs for people that helped us as we prepared the talk. Paul, Devin, Mike, and Adam worked with us as we prepared our content here. So at this point, since we just have a couple minutes, if anybody does have a question, I'll go ahead and ask. If anyone has a question, we could take it. Okay. If you would like to continue the conversation, we'll be heading into the South Seas H room for the wrap up. So thank you for your time today and appreciate your attention. Thank you.